In this video, we're going to take a look at the probability of disjoint events. I'm going to define that in a second, but first let's look at a warm-up. So let's say we are rolling 2 dice, and we want to find the probability of, let's say, roll a number that ends in a 1. Or has a ones digit of 1. Out of 2 rolls of the dice, remember there are 36 outcomes because there are 6 outcomes on the first roll times 6 outcomes on the second, so there are 36 total outcomes. So our probability would be out of 36. And then we consider numbers that end in a 1. We could just list them out. So 11, 21, 31, 41, 51, 61. So 6 out of the 36 rolls, or 1/6 of the time. So now we're going to look at probability of disjoint events. When we have disjoint events, we're going to have more than one event that we're looking at. In the warm-up, we were just looking at numbers that end in a 1. And now we're going to look at 2 things happening. So, but 2 events are disjoint, also called mutually exclusive, if they do not overlap. And to find the probability of 2 disjoint or non-overlapping events, again, we're looking at the probability of A or B, this or that happening. What we do is we add each probability together. So if we have things that are disjoint, we can just add the 2 probabilities together. So what does non-overlapping events look like? So let's take a look at what we had in our warm-up. Let's say I was thinking of rolling a number that ends in a 1 or rolling an odd. Okay, rolling a number that ends in a 1 or rolling an odd. Well, those would be overlapping because if we look, all of the numbers that end in a 1 are odd. So those events overlap because when we think about the 2 things that we're taking the probability of, there are some things they have in common. I'm going to give you an opportunity to do a couple on your own, but let's do one more. Rolling a 5 or rolling a 6. If we were, again, 2 rolls of the dice, even actually 1 roll, doesn't really matter. Rolling a 6, the only way we can roll a 6 is to get a 6. And rolling a 5, the only way we can roll a 5 is to get a 5. And rolling a 5 and rolling a 6 do not overlap. So those are disjoint. You can go ahead and pause the video and try the other ones on your own, or just go ahead and listen to me and follow along as I'm doing them. Rolling a 6 or rolling an even, those events overlap because rolling an even could be a 2, 4, or a 6, so you can see that 6 overlaps with 6. Rolling a 6 or rolling an odd does not overlap because odds are only 1, 3, and 5, and 6 is not part of that set or part of those outcomes. These next 4 examples draw on knowledge of deck of cards. So depending on your knowledge of decks of cards, this could be a little bit more challenging. Remember, a deck of cards has 52 cards, 4 suits, which are diamonds, hearts, and those are red, spades, and clubs, which are black. And then each suit has an ace, a king, a queen, a jack, and the numbers 10 through 2. So drawing a heart or drawing a 4 is an overlapping event because hearts and there is a 4 of hearts. Drawing a 6 or drawing a 10 do not overlap. A red card or a club, if you notice the reds are only diamonds and hearts, clubs are black, so those do not overlap. And drawing a heart or drawing a spade also does not overlap. Again, as long as the events do not overlap, we can use our formula. So let's now find the probability of rolling a 6 or rolling a 5 on 2 rolls of the dice. So rolling a 6 would be Oh, I'm sorry. Now that I'm thinking about that, let's do one roll of the dice, okay? So rolling a 6 would be 1 out of 6. Rolling a 5 would be 1 out of 6. And so that would be 2 out of 6 or 1/3. Let's just do one roll. That's a little bit better. How about taking a card out of a deck? What's the probability we draw a heart or a spade? So out of our 52 cards, there are 13 hearts, and there are also 13 spades. And so when I add my two probabilities together, I get 26 out of 52, or half. So half the time, if I'm picking a card out of a deck, I'm going to get a heart or a spade. And then finally, one more together, drawing a 4 or drawing a 7 out of my deck of cards. Well, I have a 4 out of 52 chance of drawing a 4, but I also have a 4 out of 52 chance of drawing a 7. And when I add that together, believe it or not, 52 does divide by 4, so I can simplify this. I have a 2/13 chance of getting a 4 or a 7. Now that I've shown you some examples, why don't you try these next 3 on your own as part of the examples, and then go ahead, pause the video and do that, and then come back and check and see. So we have the letters of the word pre-algebra. We write them all on separate slips of paper and place them in a bag. So imagine we have a bag with pre-algebra. So what is the probability of drawing an R or drawing a vowel? So picking an R or a vowel out of the bag. Well, there are 10 letters in the bag. 2 of them are R's, so we have a 2/10 probability of drawing an R. 4 of them are vowels, the A's and the E's, so we have 4/10 of drawing a vowel, which gives us 6 out of 10 opportunity or probability of drawing an R or a vowel, and that simplifies to 3/5. Drawing an L or a B, 1 out of 10 is the probability of drawing an L. 1 out of 10 is the probability of drawing a B. So we have a 1/5 probability of drawing an L or a B. And final one, drawing a consonant or drawing an E. So the consonants are P, R, B, L, G, and R. And there's 2 E's. So 6/10 for the consonant, 2/10 for the E, 4/5 of drawing those. If you want an extra challenge, why don't we try these ones down here? I forgot to attach the spinner to our picture, so we're going to skip the spinner problems. So we have our standard deck, drawing a red or a club. So the red cards, there's actually 26 red cards in the deck and 13 clubs. So that gives us a 3/4 probability of drawing a red or a club. The probability of drawing a heart or a diamond, again, both of them are red, so 13 out of 26 plus 13 out of 26, out of 52. I was thinking of my answer. And this makes sense, right? Half the deck is red cards. Drawing a 2 or drawing an ace. Well, there are 4 2s and 4 aces, which again simplifies to 2/13. Let's skip down to the last one. Drawing a 3 or drawing a red card. So there are 4 3s, and the face cards are king, queen, and jack. So there are 12 face cards. And again, we can divide by 4, so that would be a 4/13 chance of drawing a 3 or a face card. So this is a little bit about disjoint probability, again, also considered mutually exclusive.